Okay, so today we're going to have a look at limiting reagents, molar calculations where we need to work out what the limiting reagent is. So our question here is, what mass of iron is formed when 8 grams of iron 3 oxide reacts with 2.16 grams of aluminium? Okay, so what I'll do, I'll copy this balanced equation underneath. Then make it a bit bigger. And then we can put the information we've got in the question in the relevant place under the balanced equation. So for limiting reagents, we're going to be looking at the moles of the reactants, first of all. So I'd suggest under iron oxide and aluminium, we write down the mass, the MR, and the moles. So we've been given the mass, and we've got 8 grams of iron oxide and 2.16 grams of aluminium. And then if we make a note of the MR, and for aluminium the MR is 27. That's the atomic mass of aluminium. And for iron oxide we've got 2 irons and 3 oxygens. So we'll need to work out that MR, so that's 2 times 55.8, and then add 3 times 16, that's 48, that's 110, 111.6. And add them together. Gives us 159.6. Yeah. So we can put that in here. And we can also put in, we've been asked for the mass of iron, so we can put that MR in here as well, of iron, which is 55.8. So now we can look at the moles. And the way we've written it, moles is mass over MR. So we can just do the division there. So we've got 8 divided by 159.6. Which gives us 0.5013. And the aluminium, 2.16 divided by 27 is 0.08. So now we've got to work out which of these is the limiting reagent. So we've got, if this was a 1-to-1 ratio, then our iron oxide would be the limiting reagent because it's less moles, but it's not a 1-to-1, it's a 1-to-2. So if we look at the aluminium, we could see that 0.08 aluminium, moles of aluminium, would react with 0.04 moles of iron oxide. And the amount of moles we've got is bigger than that. So this is the one that's in excess, and therefore the aluminium is our limiting reagent. And then to work out the mass of iron that's formed, we go off the limiting reagent moles. And between the aluminium and the iron, with a 1-to-1, 2-to-2, 1-to-1 ratio, so we would form exactly the same number of moles. And then all we need to do is that mass is moles times mR, so 55.8 times by 0.08 is 4.464 grams. If I have a look at the question, we've got 3 significant figures, so we would say we would form 4.46 grams of iron. And that's it. That's how we work out the limiting reagent and how we work out the mass of iron formed.
Great. That sounds like sounds like just something students would be doing at GCSE, and they'll be fluent at it hopefully when they're doing A level. And the only thing that's been added is just to figure out which thing is in excess by doing pretty much the same calculation. And I'm guessing that if they assume that iron oxide is the correct one, just hypothetically, they went for 0.0503 as the 1 mole, they'll soon find out that the aluminium doesn't compute, because that'll be like 0.1 or something. So
yeah, they could work out the other way around as well. They could look at the iron oxide is 0.05 moles, so that therefore that would react with double the aluminium, 0.1, and therefore you can see that the aluminium is the limiting reagent there, because 0.08 is less than the 0.1. So you can choose either reactant to work out which is the excess, which is the limiting reagent.
Yeah, and it's great because in real life, it's basically one is going to be in excess and one is not, just for practical reasons. And it's something GCSE students might have seen in titrations, for example, so they can extend that idea that in general that's also the case.
Yeah, and sometimes they'll tell you that a certain reagent is in excess, so then you just work on the other reactant. But where it doesn't, then you have to work out which one is in excess and which is the limiting reagent.